A little bit about the unit circle and what angles, sine and cosine of our angles are. Here is a circle, and remember our unit circle, our radius is 1. And if you think about when you drop down your point and you are creating your reference triangle along this unit circle, if you drop down your point, think about this coordinate point as we would draw it normally, would be the point x, y. So if we go back to geometry and use our SOHCAHTOA rules, sine is the opposite from the angle over your radius, or your hypotenuse. So in this circle, our opposite would be y over our radius, which is 1 in the unit circle. So sine is actually equivalent to the y coordinate. For cosine, we have adjacent over hypotenuse, so we are going to be x over 1. So cosine is equal to x. And tangent is equal to opposite over adjacent. So tangent would be y over x, but since we just related y to be the sine value and x to be cosine value, tangent is really the sine of the angle over the cosine of the angle. So if you know in the unit circle, so let's say we have our unit circle, and we have the point square root of 3 over 2 1/2. This is the coordinate point for pi over 6. So if I were to ask you, using the unit circle, if I were to ask you what the sine of pi over 6 would be, since sine is y, I am just looking for the y coordinate of pi over 6, which would be 1/2. If I was looking for the cosine of pi over 6, cosine is the x value, so I just need to know the coordinates of my unit circle, and the x value is the square root of 3 over 2. And since tangent is sine over cosine, if I want the tangent of pi over 6, sine was 1/2, cosine was the square root of 3 over 2, so tangent is going to be the root 2 over, or the over 2 over 2, I can multiply by a 1 and they would cross off, so I end up with 1 over the square root of 3. Which, if I rationalize, I'm going to get the square root of 3 over 3. So knowing the coordinate points on our unit circle, we can evaluate some trig functions.